That's 0.255 G. Why did we write that? Why did we do that? So what this means is the thrust of the car, the force it's applying is a quarter times the weight of the car. Okay? If you're a rocket and you want to take off, the thrust that you have to apply has got to be greater than the weight of the car, weight of the rocket. So most rockets apply a thrust of about 1.7 times the weight of the rocket on the launch pad. Okay? What happens to the rocket? If the thrust remains the same, the weight is decreasing. Okay? And it's accelerating at a greater and greater rate. Yep.
So you said that value represents that force is going forward with the weight?
So the weight of the car is mg, and the force you've applied, the weight of the car is mg. The force you've applied is ma, which is m times 0.255 g. 0.255 mg. That's the weight of the car. Okay? So that's why it's useful to do it that way. Okay? Write it that way. That gives you a better sense for what that number is. Yep.
So you plugged in 2.5 for G?
No. This was your acceleration.
Okay.
All I did was multiply this by 1. G is equal to 9.8 meters per second squared.
Okay.
So this is 1. And the reason I did that was now I can cancel this guy. And 2.5 divided by 9.8 is 0.255.
Okay.
What is the net force on the car? So this force was what was making the car accelerate, and that's equal to mass times acceleration. Okay. Well, okay. Now I want to. $2,500 newtons. Okay, so small cars, a Honda Civic is actually about 1,500 kgs. Okay, so this is I don't know what car this would be, but anyway. So this problem says a rocket sled accelerates at a rate of 49 meters per second squared. So this is a sled and the acceleration is 49 meters per second square. And then if you divide, you write it in terms of G. What does that mean? If you're sitting on the rocket, the force that the seat is applying on you is 5 times your weight. Okay? You won't be able to come out of that seat. All right, calculate the horizontal component of the force the seat exerts against his body. Compare this using the weight. Okay, so force is mass times acceleration. And again, so now it's convenient to write this like that. So the mass times 5g. So the horizontal force is 5 times the weight of the object. Calculate the direction and magnitude of the total force the seat exerts against the person's body. Okay, so now we'll look at just the person. Okay, what is the force that the seat is exerting? Okay, this is the force of gravity. So there is the normal force, and there is the horizontal force. So the net force on the person, XY, the net force that the seat exerts on the person, 5 mgi plus mgj. Yeah. the magnitude of the force and this is square root of 26. And so the net force that the seat is exerting on the person is in this direction. This is 1, this is mg, and this is 5 mg. Okay. You guys understand that? I'm sorry?
What's the unit for a Newton?
No, Newton is a unit. It's a unit for force.
Or,
Newton is 1 Newton is, so here's how you figure it out. Equal to mass times acceleration. So it's kg meters per second squared. So we write this is a Newton in base units. This combination of base units is named after, when you give it a name, this name is normally honoring the scientist who did work in that area. Yeah. Yep.
And for the formula beforehand, what was the Fn?
That was the normal force that the seat is exerting on you.
Is it
So-
total number of forces added together to create the magnitude?
All right, so what this is saying is the following. So when you're sitting, now only force is this normal force against the gravity. But now if I'm accelerating with a force of 5, with an acceleration of 5g, I need a horizontal force. So those are the two forces.
So you're saying the absolute value of the vector?
No, not absolute value, that's the magnitude of the vector.
Oh, the magnitude.
Yep.
Okay. So magnitude of the vector F is equal to the components, the x and y components?
Yeah, you've used this formula before. A vector axi plus ayj. The magnitude of a is ax squared plus ay squared. That's what happens. Okay. Yep.
And that's just from like Pythagorean theorem, right?
Yep.
Yeah.
Yep. Have you guys been keeping up with the quizzes? Who hasn't done them? Let's see a show of hands. Okay. And of course, by this weekend, you want to be done with quiz 5, chapter. Okay. So a fireman has a mass m, force he must apply to the pole. Okay. You know, where did you need fire trucks? In big cities? In big cities, land is expensive. Okay, so here's a public building, and you know, you can't have a large footprint for the fire station. Okay, so here's where you park the fire trucks, and this is where the firemen live. Okay, they have to wait. So as soon as they hear a alarm, what they do is they want to get to their fire truck as fast as possible. They could climb downstairs, they could jump, but jumping down is not good for their knees. So here's the next best thing. They put these poles, and you slide down these poles. Okay. Now, gravity is pulling you down. So what do you do if you grab onto the pole and apply a force in that direction? then your acceleration will be smaller than g. Okay? And smaller the acceleration, longer your knees last. That's the idea. All right, so he slides down the pole with an acceleration a. Write an equation giving the vertical force. We want to write an equation that gives this force he must apply to the, okay, so now I'm not going to draw anything else. So here's the weight and here's F, okay. So we'll take, and his acceleration is in this direction, so we'll take this direction to be positive. So that's equal to his mass times acceleration. Okay. So the force he needs to apply is mg. So if he accelerates down at g, if the acceleration is equal to g, then the force he's applying is 0. Okay? So of course, if you don't hold on to the pole, you're applying a 0 force and your acceleration is equal to g. Okay? If acceleration is 0, so if you're sliding down at a constant speed, that means the force you're applying is equal to the weight, your weight. Okay? So you're applying a strong force. Okay? So the stronger you are, the longer your knees will last. Okay? You slide down. So if his mass is 90 kgs and he accelerates at 5 meters per second, what is the magnitude of the force? So you just calculate the force. That's 90 kgs, that's 9.8, that's 9.8, and that's 5 meters per second. So you just put those numbers in. 5 meters per second is half of that. So the force he's applying is half his body weight. Yeah. All right, this problem says a truck collides with a car, and during the collision, the net force on each vehicle is essentially the force exerted by the other. Okay, so, and Newton's third law says, action and reaction are equal and opposite. Okay, so, truck. Okay. So, action and reaction are equal and opposite. What would you rather be on? I'm sorry? Yeah, the forces are the same though. So why would you want to be on the truck? That's the correct answer.
The forces are distributed,
What's that?
the forces are distributed, less acceleration.
There you go. Acceleration is bad for your health. Okay? Force is mass times acceleration. So if you're in a vehicle there where the mass of the vehicle is greater, then your acceleration is smaller. Okay? Okay, so the car was going in this direction, it gets stopped, and your acceleration is in this direction. The truck was going in that direction, it doesn't get stopped. It'll go plow through the car, and the acceleration will be smaller. Okay. All right. Suppose the mass of the car is 550 kgs, and the mass of the truck is 2,200 kgs. So the mass of the truck is 4 times greater, and the acceleration will be 4 times smaller in the truck. Okay. And the magnitude of the truck's acceleration is 10 meters per second. Find the magnitude of the car's acceleration. So the car's acceleration will be 4 times greater, which will be 40 meters per second square. So the force on you will be, okay, so the force on the car is equal to the force on the truck. The magnitudes, and so the force on the car is mass of the car times acceleration of the car. and this should work out to 40 meters per second. Yep.
You go back to slide.
So that's why people drive in bigger and bigger vehicles. But what is the problem with that?
Space,
Hmm?
space.
Your biggest concern is climate change. You're putting more carbon dioxide in the atmosphere. All right. If your car gets stuck, what's that?
Get a tow truck.
Get a tow truck.
Have to give it a surface of your grip on.
What's that? Yeah. So first thing you do is you tie a rope on it and pull. Okay. Now what this problem will show you is, let's say you apply 100-pound force and you pull on the car. Now if you can do the following, okay, so here's your car, tie a rope, and you can tie, if you can tie the rope to a tree, or what you could do is you could tie it to a car in the parking lot. Tie this rope, and now you push with a force of 100 pounds. What you get is, so this is a force multiplier. You push with a force of 100 pounds, what you'll get is 400 pounds. So this is how you get your car out. Okay.
Or an uprooted tree.
What's that?
Or an uprooted tree. You either get the car out or the other.
Well, anyway, that's better than pulling this way, all right?
Yeah, I can agree with that.
Yeah. All right, so this is the force multiplier. Okay, so let's see the calculations. Do you guys understand what's going on? Get the car out of the mud by exerting a perpendicular force of 610 newtons, and the distance she pushes in the middle of the rope is 1 meter. Okay. So what you want is the stiffer the cable, the greater the force multiplication. While she stands 6 meters away from the car, so this is 6 meters, and 6 meters away from the tree, so this is 6 meters. What is the tension in the rope? So what is the tension in the rope? That's the force on the car when she applies a force of 610 newtons. 610 newtons is roughly her weight, so she's leaning against the rope. Okay, so here's how you solve this. We'll call this theta, we'll find that in a second. This is 1 meter, this is 6 meters. So tan theta is 1/6. Theta is tan inverse of 1/6. Okay, now, so what is happening is this component of the tension, these two components of the tension are balancing this force. We'll say that this is an equilibrium, this point is at rest, so the sum of the three forces acting on this point, the knot must be 0. Okay, so this component of the tension plus this component of the tension should equal F. All right, so let me write this over here. So this angle is theta. So tension times sine theta plus tension times sine theta should equal F. And in this case, theta is 9.5. So the tension is, and you'll see that smaller this angle is, bigger this number will be. Okay. So you see what you got was the tension in the rope is, so the tension in this rope is 3 times the force you apply. You effectively made yourself 3 times stronger by being smart. Okay. And the stiffer this rope is, smaller this angle would be, bigger this number would be. Okay. So that's how you get your car unstuck. All right, so this problem says what force must be applied to a 100 kg crate to cause an acceleration of 2 meters up the plane. Meters per second square up the plane. So the acceleration is that. Okay. Now, what are the forces on this guy? So we saw that mg is the force, but mg sine theta is the force in this direction. Okay. So this force minus mg sine theta must give you this acceleration. So along the incline, F minus mg sine theta should equal mass times acceleration. Okay. So the force you need to apply is mg sine theta plus ma. All right, so the force, and I'm not going to put in the numbers. Sine 30 is a half. A is 2 meters per second square. Did you guys understand that? I wrote A equal to 2 meters per second square equal to 0.2 g. Essentially, g is 10 meters per second square. 10 times 0.2 is 2 meters per second square. All right, so the force you applied on this box to push it up is 70% the weight of that box. That's why you have these inclined planes. You want to lift something up, you can lift it straight up. The force you would have to apply is equal to the weight of the object. But if the object is too heavy, then you use an inclined plane. What is it? It's a machine that's letting you lift this object up with a smaller force. Okay? And if this angle is smaller, if the inclined angle is smaller, you would apply an even smaller force. Okay. What is the price you would pay if the angle is smaller? You're applying a smaller force. The length of the incline is greater. Okay. You guys understanding that? All right, so this problem says the velocity of a 3 kg object at t equal to 6 seconds and t equal to 8 seconds are, so here's the velocity initially and there's the final velocity. If the object is moving at constant acceleration, what is the force acting on it? The time over which that change happens. Okay, this is 2 and 3 minus 5 over 2, so negative 2.5 I. That's 4 plus 6, 10 divided by 2, that's 5. 4 minus 4, so that's 0. Okay, so that's the acceleration. And what is the force acting on it? The force is just 3 kgs times the acceleration. Okay, this problem says two forces are acting on a 5 kg object that moves with an acceleration of 2 meters per second in the positive y direction. If one force acts in the positive x direction and has a magnitude of 12 newtons, what is the magnitude of the other force? All right, so the object accelerates in this direction. Here's force 1, 12I plus 0j. What must be the direction of the other force for it to accelerate in that direction? What's that? So you can see that the second force must be some x component of the acceleration. And the y component is what's making him accelerate in that direction. Okay, so F2 must be somewhere like that. So the acceleration vector is 0I plus all right, so if you look at the x comp 1x plus F2x should equal mass times AX, which is 0. So F2x should equal minus F1x. Okay. So F2x is minus 12 newtons. Let's look at the y component plus F1y is 0. So F2y should equal, the mass is 5 kgs times 2 meters equal to 10 newtons. Okay. So the second force, F2, is minus 12I plus 10j. and F1 was equal to 12I. And the net acceleration of the object was 0. All right.